Hey, what's up everybody? In this video tutorial, this is our part one of creating sort of the mechanism that makes up our automata. So if you haven't already watched it, there's a video out there that shows how to create the box, the automata box, using the parts that come with our automata kit for core training. There's two different videos. There's one that shows you how to do a top-down approach on assembly, and there's also one that shows you how to do a bottom-up approach. It does not matter which one that you pick, you're still going to have to make the box. So that's totally up to you. So what we're going to be doing now is I'm going to be showing you where you can locate parts to use to create the first part of your mechanism that goes with automata. So I'm just going to drag over the Google Drive, okay, and this is what you're going to be seeing on the Google Drive, all right, for our course. So if you look here for automata resources, you're going to be seeing the parts I'm going to be using are going to be these automata parts right here, and you can see my name is on them. What is the difference between my edition and the PLTW edition? Well, in my edition, I am using a 1/4 inch round dowel for the axle, and I'm using 1/4 inch square dowels for follower rods. In the the PLTW edition, it's going to be using the 1/4 inch square dowel for the axle, and it's going to be using 1/4 inch, I think they're 1/4 inch round dowels for the follower rods on top. And if you're asking what is the difference and why does it matter? Well, if you have things on top of your automata that you want to possibly spin, then you're going to need to go with the 1/4 inch round dowels with the PLTW parts. If that doesn't matter to you, all right, then you can go ahead and use the square dowels for the follow rods on top. So just to kind of give you a clarification on that. All right, so in my case, I'm going to go ahead and use the parts that I have provided to you. So what you're going to have to do is you're going to have to download these parts, okay, and have those available to you so you can upload those into Fusion. So I'm going to go ahead and just begin downloading all these, okay, until I have all of those parts that I can use for Fusion. So once you have downloaded all of those parts, okay, I'm going to go ahead and just pull this off the screen. Okay, now what I'm going to be doing is going into my project 4.2.5 Automata Design Challenge folder that I previously created, and now I can begin uploading those parts to use for making my assembly. So I'm going to go ahead and go to upload. I'm going to select those files, okay, and I believe it's going to be coming all the way down here to shaft collar. Those are 3, 4, 5, 6, 7 parts. Yep, that sounds about right. So I'm going to go ahead and do an open and do an upload. Okay, so as this status is starting to check off as complete, you're going to be starting to see those 7 parts show up over here on the left-hand side. All right, so now that I have that, now I'm just going to be dealing with my box. So like I said, it doesn't matter which one you pick, top down, okay, or bottom up, as long as you have that assembly in front of you ready to go, that's all that matters. Everything else is basically going to be clicking together. All right, so in this case, I'm going to start here at the top, and I'm going to be searching over here for my automata rod guide. So I'm going to go ahead and just drag this over the line. And that's going to be coming in, grabbing by the grip. I'm going to pull this up, get it out of the way, and say, okay, I'm going to need 2 of these rod guides. So I'm going to pull those over, okay, say okay. All right, and now we're going to just start focusing on getting these to attach to this assembly. So at this point, I can go ahead and hide the data panel, get myself a little bit more screen real estate, and now we can get started. So these are just going to simply snap right in. Okay, so I'm going to come up here, go to joint. I'm going to go ahead and find the exact dead center of this. I like the orientation, so I'm going to pick on that. And I'm just going to bring that right over here to the hole. Okay, find that origin that's right there on top, and we can see how that's just going to come right in. Just don't forget, you always have the ability to do the flip in case something silly happens. Last thing I'm going to be checking on is coming here to motion and making sure that's a rigid joint. I'm going to go ahead and say okay on that. So we can see that has been placed. All right, I'm going to go and do the same thing for the second one. Going up here to joint, finding the correct origin here on top, and then bringing that right here to the top of the hole. Okay, watching that snap right in. Going to motion, verifying that that is rigid. I'm going to go ahead and say OK. So if I actually try to grab a hold of the rod guides, okay, and pull those out, nothing is going to happen. Okay, so nothing is pulling off of that, so those are fully constrained. All right, so the next thing I'm going to bring in is I'm going to come back here and open up my data panel. Now I'm going to be looking for the axle. So here's my Automata axle. So I'm going to go ahead and just pull this in. And once that comes in, it's going to be coming to the origin. All right, and I'm going to go ahead and just pull that off with the grip. Okay, now don't forget, when parts come in, all right, if they're oriented a little bit weird or whatever, don't forget that you still have the ability to use your dials to get those sort of nudged in the right direction. Okay, you can always take care of that. This is coming in just fine. I'm going to go ahead and just say okay. All right, so the axle, okay, is going to be spinning inside of these arbor holes that are on the sides of our Automata box. All right, so one thing I have to clarify here is that I'm going to be giving you some parts, and when I'm talking parts, I'm talking about the shaft collar, I'm talking about the crank handle. Those are going to be laser cut from 3/16 plywood. 3/16 as a decimal is 0.1875. So when I slide this axle into the holes, I have to make sure that there's enough of that axle hanging over the side of it so I can go in and glue in my actual shaft collars. That might not make sense right now, but it will here in just a minute. So in this case, the axle is going to be spinning inside these holes. All right, so if you're thinking about joints, all right, we're not going to be using rigid. We're actually going to be using something called revolute. So I'm going to come here to the end of my axle, okay? I'm going to be picking on that joint origin. And now what I'm going to do is I'm going to flip this around, come here to the top of the hole and find this joint origin. So that's going to come in. The problem is if we go here to motion tab, it's on rigid. I want to switch that to revolute. And it's even going to give you a preview on what that joint is going to do. Now, the problem that we also have is the fact that it's going to be flush right now with the top of this surface that makes up our side. All right, so if I come back here to position, all right, you never have to wonder which one is which. Instead, you can come right here to this triad and you can pull on the arrow and you can pull it out in the direction that you want. So we can see that is now sticking out beyond the actual side. All right, and that needs to come out the distance, the thickness of our plywood, which is what makes up our shaft collar, which in this case, and I can see that that's positive, I'm going to say that this is 0.1875. So now that's sticking 0.1875 beyond the side. So I'm going to go ahead and say okay. All right, so my excuse me, my axle is in. So I'm going to turn this back into home view. And now I'm going to come back over to my data panel and I'm going to be searching for my shaft collar. All right, so the shaft collar is just going to be sort of like this cylindrical sort of ring with a hole in it. I'm going to bring that in, and I don't know why Fusion is chugging, but it is. Uh-oh, that's not good. Let's pause this just for a second. All right, so it finally came in. All right, I'm going to grab this by the grip and I'm going to pull that off and I'm going to say okay. And while it's acting kind of goofy here, I'm going to go ahead and just do a quick save just to get that guy saved. All right, so I'm also going to need a second shaft collar. I'm going to pull that in. I'm going to use the grip, pull this off. Okay, and now I'm going to go ahead and say okay. And I'm going to get rid of my data panel, shove that back in. All right, so shaft collars. The whole point of a shaft collar is to keep the axle from sliding back and forth, all right? So the shaft collars are going to be glued to the axle on both ends, but they are not going to be glued to the box, okay? Why? Well, if you glue them to the box and the axle is glued to the shaft collar, this thing is not going to spin. All right, so we're just focusing on gluing the shaft collar to the axle only. All right, so if you're thinking about that gluing sort of thing that we're talking about, that means we're going to be using a rigid joint. So I'm going to come right in here to the shaft collar, find my correct joint origin, I'm going to bring this right here to the end, okay, of the actual axle. I'm going to find that joint origin, and that's going to come in. Now, the issue is that the last thing I put in was revolute, so that's still stuck on revolute. I'm going to go to motion, switch this to a rigid, all right, and we can see that those two are attached, okay, and we can say okay. All right, so we can see, I think that's right, isn't it? Something happening here. Oh, and I just realized what my mistake was. All right, so if you ever have to go back into an origin and make a fix, so I can see that that is not flush with that top face, okay, that means I forgot to do a flip. All right, here's how you can track that down. Of course you can undo and go back, but it's already done. Let's just fix it while it's here. All right, so over here we can see joints. If we hit the flyout next to joints, it's going to be telling me what my last one was. So I can right click here on rigid and say I want to edit the joint. All right, that's all looking good. I wonder why that's acting the way it is. Let's just go ahead and with an OK. Let's pull that. That is still not acting right. Okay, I'm not liking it, so I'm just going to go ahead and toss it. Okay, my shaft collar is still up here. Let's try that again. Okay, so let's go to joint, come here right to the ring. We have that correct origin. Now we're going to come right in here, go to this ring. That comes right where it's supposed to go. My motions are rigid. I'm going to go ahead and say OK on that. And it's still spitting that out. And the only thing I can think of is that it is thinking that there's an offset there. And I did not put in an offset. Let's see what the flip does to it. And now weird, the flip worked. Even though in the preview it was showing it was actually correct. I don't know, but it works. All right, let's go to this side. Maybe it will behave a little bit better. So let's go ahead. We're going to go into joint. I'm going to come here to this top surface, find my origin. Okay, now this time what I'm going to do is I'm going to come right here to this axle on this end. So it's looking good. But the thing is, if I'm looking at this from that front view, we can see that there is a gap here. All right, so the shaft collar needs to slide back against the face of this box. Now, I've already given you an axle that's going to be able to accommodate the length of the box. It's also going to be able to accommodate 2 shaft collars and a crank handle. All right, so if you're wondering where I'm getting this distance, it's because I can come here, grab the arrow, pull it back, and in this case, just something to look out for. This is showing a negative, so I'm going to say this is negative 0.1875. That's going to be the thickness of our crank handle, which you guessed it, is the same thickness of plywood that I made the shaft collars from. All right, so that's going to send it back. I'm going to go ahead and just verify that this is made of rigid joint, and I'm going to go ahead and say OK. All right, and that behaved like it should, unlike the last one, but I don't know. All right, so now that I have that done, okay, I'm going to come back in here to show my data panel. Now I'm going to bring in my crank handle. I'm going to drag that over the line, and let's see if crank handle is going to behave itself. All right, so it showed up, it's behaving. I'm going to go ahead and just grab this by the grip, pull it out, say OK. All right, and now I can go ahead and get this guy attached. All right, so I don't need my data panel. I can send that back over. Now I can come up here, go to joint, and now I'm going to be just focusing right in here on this ring. I'm going to find that joint origin, and I'm going to have that thing come right in here to this joint origin. All right, that's going to slide right into place. And once again, the motion I'm going to be looking for is a rigid, and I'm going to go ahead and say OK. All right, so at this point in time, I'm going to go ahead and just save this just to make sure everything is saved up until this point. Let's start seeing how this thing is behaving. All right, so what I'm going to do is if you remember, there's only one revolute joint. All right, so once again, if you need to find where your joints are at, you can come here to the joints folder. We can hit the flyout, and now we can see that revolute is number 7. What I'm going to do is I'm going to see how this thing is actually acting. I'm going to right click on revolute number 7, okay, and I'm going to come down here and pick on animate model. And now what we're going to be seeing is once that is going, hopefully it's showing the wood grain moving, and it is. All right, we can see the shaft collar and the axle, the crank handle, and the other shaft collar, if I can get it to orbit, are all behaving the way that they're supposed to. All right, so we can see that this is really actually working. Okay, now I'm going to go ahead and hit escape to kill that, to cancel it. All right, now I can continue working on the rest of these parts that are going to sort of mechanize the first portion, or part one of this video tutorial. Okay, so we have it saved. We have everything in here. Now I'm going to go ahead, show our data panel again. But this time I'm going to come over here and find Automata Rod. Okay, so going to Automata Rod, I'm going to drop that into the window. I'm going to use my grip to pull it off, and I'm going to say OK. I don't just need one, I'm actually going to need two of these. So I'm going to drag in the second one. Okay, bring it up here, and I'm just going to say OK. All right, so what I think I'm going to do on this next one is I don't know, we can kind of assemble things, ahead of time, and then we can put those where we want those to go. Even though if we have parts that are ghosting through other parts, it doesn't matter. It's not real life. We can make it work. All right, so in that case, I'm going to go ahead and just pull over my Automata follower. Okay, grab it by the grip, pull that up and say OK. And then grabbing in a second one here, grabbing it by the grip, pulling up and saying OK. All right, so plain and simple, our follower rods, the base of it needs to go in and hook up and connect to the base of this hole. All right. All right, so we're probably going to need some information from this, like how far is it? And I can't seem to go in and look at that. So I'm just going to go into the actual Automata follower itself. So down here in the timeline, okay, I can right click on this and say I want to edit that feature. We can see that we cut that square hole down a distance of 0.25. All right. Sometimes you've got things in the way, work planes, and it just doesn't want to behave. I just want to show you what the depth of that square hole is. All right, so I can go ahead and close out of this. All right, so we're back in the assembly now. Okay, and now what I'm going to do is I'm going to come up here, go to joint, and I'm going to just zip right in here, and I'm going to find this dead center point. All right, I like that guy, so I'm going to pick it. And now what I'm going to do is looking at the bottom of my follower rod, I'm going to find the same origin and bring it right there to it. Now the problem is that the follower rod does not go all the way down, okay, into the bottom of that hole. All right, so what I'm going to do is I'm just going to bring this up a distance of negative in this case. In my case, it's saying it's indicating negative, but it needs to go in there a distance of 0.25. So it'd be negative 0.25. All right, the motion that we're looking for is a rigid. I'm going to go ahead and say OK. So if I grab a hold of this now, we can see that those two are working together. All right, so I'm going to go out and go to joint again. Same as last time, I'm going to come right here to the dead center and pick on that. And now I'm going to look at the bottom of this follower rod and find this origin right here. Okay, so we need to shove this up, and that needs to go up a distance. In my case, it's going to be a negative 0.25. Okay, and that is now going to be sitting at the bottom, okay, of that square hole. And I'm going to say OK. All right, so if I grab this, we can see that those are now working together. All right, so now all we have to do is just take our follower rods with the followers at the bottom and just get those to slide inside of the rod guides. All right, so I'm going to come out here and go to joint. Okay, and in my case, I don't know. Let's just go ahead and we can do it from here. This will work. I'm going to go ahead and just put my joint origin right here at the top of the follower rod. And I'm going to say I want that to meet right here at the dead center. All right, so right now our motion is it's a rigid. It's not going to be a rigid. It's not going to be a revolute. That wouldn't work. But it is going to be a slider. So I like how that looks. So I'm going to go ahead and say OK. Okay. And right now that follower rod is going all the way down through it. Now if you're looking at this and panicking, it's okay. We can pull up on it and we can see it's behaving the way it should in real life. And then we're going to do the same thing for the next one. Going into joint, coming here at the top, okay, picking on this. Okay, now we can come right here to this origin. All right, it's going to remember a slider from last time. If it isn't, you can go to motion, switch to slider, say OK. And once again, we can come out here, pick on a rod, we can pull this up, and it's going to be behaving the way it's supposed to. All right, so that is part one, okay, of the sort of mechanism assembly. So all that leaves us then is, with part two, where we're going to be dropping in the particular cams that we want, orienting those in the right direction, and then applying our toppers to the top of our follower rods, and then constraining this to make it behave the way that it would in real life. And that's going to be using some pretty cool stuff. So we'll get to that. But there you go. That is the first part of how to add joints and constrain your automata box and all of your mechanisms.